The drive for Ersatz, substitute materials, was far more than a simple, pragmatic wartime expediency. It was cemented as a fundamental, absolute cornerstone of Nazi ideology, known as autarky, the aggressive national goal of achieving total economic self-sufficiency. Adolf Hitler held an almost obsessive belief that Germany's catastrophic defeat in World War I was directly attributable to the crushing, prolonged Allied naval blockade, which ruthlessly starved the nation of vital imports like food, metals, and natural rubber. To violently avoid any repeat scenario, his entire pre-war economic planning, specifically formalized in the monumental four-year plan, launched in 1936, prioritized insulating the Third Reich from all foreign dependence through scientific means. Germany's natural geography tragically lacked massive, easily accessible petroleum reserves, high-grade iron ore, and natural rubber plantations, making the scientific push for domestic synthetic substitutes a core, existential strategic imperative for achieving Hitler's territorial ambitions and sustaining a future total war. Despite massive internal investments in Ersatz, Germany entered World War II critically and precariously dependent on foreign sources for several key raw materials absolutely essential for modern mechanized warfare. The most glaring, fatal vulnerability was petroleum, with less than 10 of its fuel needs met domestically, requiring the swift conquest of oil-rich regions like Romania. Even its vaunted iron and steel industries, the vital backbone of the Wehrmacht's armaments, were dangerously reliant on high-grade iron ore imports, primarily from neutral Sweden. Natural rubber, non-negotiable for vehicle tires, tank tracks, seals, and electrical insulation, had to be imported almost entirely from distant Southeast Asia. Senior German war planners knew with cold certainty that any sustained naval blockade or the loss of access to crucial neutral trade partners would quickly cripple the entire motorized component of the German military machine. This inherent, inescapable resource poverty was the fatal, irreconcilable contradiction at the very heart of the Nazi war plan. The four-year plan, launched in 1936 and nominally overseen by Reichsmarschall Hermann Göring, was a grandiose command economy effort demanding that German science and industry deliver all essential synthetic substitutes in massive, unsustainable industrial quantities by 1940. While it dramatically succeeded in prioritizing the rapid development of essential ersatz technologies and the accelerated expansion of existing plants, the plan ultimately and fundamentally failed to achieve the promised goal of true self-sufficiency, autarky. The production quotas for essential strategic materials like metals, fuel, and synthetic textiles were constantly and significantly missed, a failure often cynically masked by political hyperbole and manipulated official statistics. This persistent underlying production deficit forced the German military leadership into a constant strategic reliance on conquering resource-rich territory like the oil fields of Romania, the coal of the Ruhr, or the grain lands of Ukraine, purely to fill the strategic gap left by the grossly insufficient domestic ersatz output. The most crucial, expensive, and resource-intensive ersatz project was the all-or-nothing effort to produce synthetic fuel from Germany's vast domestic coal reserves, a colossal undertaking known as Kohleverflüssigung, coal liquefaction. The primary, highly complex method adopted was the Bergius process, pioneered by Nobel laureate Friedrich Bergius. This method involved directly liquefying finely crushed coal dust by treating it with pressurized hydrogen gas at extremely high temperatures, up to 500 C, and immense pressures, up to 700 atmospheres, within colossal thick-walled reaction vessels using specialized catalysts. Although technologically complex, highly energy inefficient, and demanding enormous initial capital investment, the Bergius process was strategically vital because it produced high-octane gasoline of sufficient quality, suitable for the Luftwaffe's high-performance, supercharged aircraft engines. By the later peak of the war, this process alone was responsible for producing the vast majority of the Reich's combat-essential aviation fuel. In parallel with the direct liquefaction of the Bergius process, German industry also extensively utilized the Fischer-Tropsch (FT) process for synthetic fuel production, favored for different product needs. Developed in the 1920s by Franz Fischer and Hans Tropsch, this was an indirect form of liquefaction. It involved first converting coal into syngas, a basic mixture of carbon monoxide and hydrogen, and then, using iron or cobalt catalysts at lower, more manageable pressures, rapidly transforming the syngas into liquid hydrocarbons, typically focusing on producing essential diesel and kerosene fuels and specialized lubricants. The FT process was generally deemed more economical for producing lower quality vehicle fuel, while Bergius focused on aviation gasoline. Together, the strategic network of over 25 synthetic fuel plants across Germany and occupied territories rapidly became the irreplaceable lifeblood of the Wehrmacht, supplying over 90% of aviation gasoline and roughly half of all military petroleum by 1944. The entire synthetic fuel and chemical program was overwhelmingly dominated and executed by IG Farben, the massive German chemical and pharmaceutical conglomerate. IG Farben invested billions of Reichsmarks in synthetic research, effectively becoming the Nazi state's indispensable partner for achieving autarky. The company controlled the vital patents and designed and built the nation's largest synthetic fuel and Buna rubber plants, viewing the war as a prime opportunity for unprecedented, state-funded expansion and colossal profit. This tight, almost symbiotic relationship between the totalitarian Nazi state and the massive chemical industry ensured that virtually all national resources were ruthlessly channeled toward creating Ersatz, regardless of the immense long-term economic cost. IG Farben's technical expertise was unsurpassed, yet its ambition also led it to construct its infamous Buna rubber plant, Auschwitz III Monowitz, immediately adjacent to the Auschwitz concentration camp, relying entirely on slave labor to fuel its ersatz goals. After fuel, natural rubber, caoutchouc, was recognized as the second most critical, scarce resource Germany severely lacked. Rubber was essential for vehicle tires, tank tracks, the critical seals in engines, gas masks, and electrical insulation. The ersatz solution was Buna rubber, a complex synthetic copolymer created through the industrial polymerization of butadiene with sodium, Na. The functional name Buna was derived directly from these two core chemical components, Bu, butadiene, and Na, natrium-sodium. IG Farben's Buna Werke in Schkopau began large-scale production in 1937, aiming to fully free Germany from its reliance on volatile overseas plantations. While Buna was a technical success as a man-made polymer, it was notoriously difficult and time-consuming to process and initially suffered from poor durability and lack of elasticity compared to its natural counterpart, causing early and persistent reliability problems for the Wehrmacht's motorized units. The desperate, escalating push for synthetic rubber autonomy tragically led to one of the darkest and most morally reprehensible chapters of the entire ersatz economy, the construction of the massive Auschwitz III Monowitz industrial complex. IG Farben strategically built this immense synthetic rubber and fuel plant immediately adjacent to the Auschwitz concentration camp to guarantee an inexhaustible, easily controlled supply of slave labor. The company ambitiously planned Monowitz to be its single largest overseas production plant, capable of churning out colossal quantities of Buna. Despite the immense documented human cost and the unimaginable suffering inflicted upon the camp's prisoners, the Buna plant at Auschwitz never achieved meaningful, sustained production capacity before the war ended. The entire Monowitz project became a harrowing symbol of the immense immoral resources the Nazi regime was willing to expend to desperately sustain their Ersatz war machine. The universal Ersatz imperative extended its reach to virtually every sphere of German industrial and civilian life. Since Germany critically lacked access to foreign cotton and high-grade wool imports, massive new industries were rapidly created to produce rayon and cellulose fiber textiles for military uniforms and all civilian clothing. Crucially, synthetic lubricants, Ersatzöl, were created from oxidized coal byproducts to keep the nation's entire fleet of machines and tank engines running under constant stress, though these inferior. Oils often caused severe engine fouling and significantly reduced overall service life. Even plastics, like PVC and polyurethanes, were rapidly developed and mass-produced by IG Farben to urgently replace metal and other scarce materials in everything from vital aircraft cockpits to basic small arms components. The cumulative result was an entire economy defined by endless, complex technological workarounds and a creeping, undeniable decline in the quality of every single manufactured good. For the average, struggling German civilian, Ersatz rapidly became a potent, daily symbol of wartime austerity, declining morale, and painful scarcity. The most tangible and visible manifestation of this was in food and beverage substitutes. Real coffee, imported tea, and chocolate quickly vanished from shelves, cynically replaced by bitter mixtures made from roasted acorns, chicory, rye, or barley. A dark, flavorless, disappointing concoction universally known simply as Kaffee Ersatz. Bread, Kriegsbrot, or war bread, used potato meal, chemical extenders, and eventually even wood flour to replace critically scarce wheat. Tobacco was aggressively extended with various herbs and dried leaves. This steady, painful decline in the quality of daily life, the lack of butter, the thinness of clothing, and the bitter taste of Ersatz beverages was a tangible, inescapable reminder to the German populace that the promise of a swift, victorious, resource-rich war had spectacularly failed to materialize. The shortage of natural, durable fibers like imported cotton and jute throughout the Reich drove chemists to attempt the creation of ingenious, though ultimately impractical, fiber substitutes. Chemists feverishly developed methods to successfully spin yarn directly from paper fiber, cellulose, which was then utilized to create everything from socks and towels to civilian outerwear and even light military gear. These paper-based textiles were technically inexpensive and lightweight, but were notoriously and practically fragile, deteriorated rapidly when exposed to moisture, and could often only be cleaned with a dry brush or a rubber eraser, not traditional water washing. While these materials represented a desperate pinnacle of German Ersatz chemical ingenuity, their severe, documented poor performance in practical use cemented the civilian stigma of the term Ersatz as tragically synonymous with inferior quality and low durability. Even military rations, which the Nazis prioritized to avoid the morale-breaking starvation of the World War I era, saw Ersatz components creeping in. While privileged frontline troops initially received decent caloric rations, the necessary components often had to be substituted. Synthetic fats were created from oxidized coal derivatives and were extensively used to replace critically scarce butter and animal fat in field kitchens. Hardtack bread was constantly supplemented with fillers. The Wehrmacht was forced to rely increasingly and precariously on non-standardized food supplies stripped directly from occupied territories. However, unlike the total collapse in civilian supply, the German military leadership made concerted and successful efforts to maintain the caloric content of frontline soldiers' rations based on the paranoid belief that adequate nutrition was absolutely essential to maintaining combat effectiveness and preventing the internal collapse that had defined the end of 1918. The constant, inescapable need for substitutes had a severe, cumulative, and systemic degrading effect on the quality and mechanical reliability of Wehrmacht equipment, a problem that sharply accelerated after 1943. Critical, specialized alloying metals like nickel, chromium, and tungsten, essential for hardening steel armor plate and manufacturing durable tool parts, were increasingly unavailable or routed entirely to specific projects. The only solution was to substitute these metals with inferior alternatives, resulting in tank armor that was visibly more brittle and dangerously prone to spalling, and engine components that failed prematurely. The term Ersatz on the front line meant shorter service life, significantly increased maintenance burdens, and a higher rate of catastrophic mechanical breakdown for German tanks and vehicles, granting the Allies a hidden advantage in long-term battlefield endurance. The heavy reliance on synthetic lubricants, Ersatzöl, derived indirectly from the Bergius and FT coal processes, presented a specific and crippling technical crisis for the sophisticated high-tolerance German military engines. While sufficient in sheer quantity, the synthetic oils had different, inferior chemical properties than natural petroleum-based oils. They often left behind corrosive residues and acidic byproducts, leading to rapid and severe engine fouling, accelerated corrosion, and critical wear in the meticulously engineered Luftwaffe aircraft engines and Wehrmacht tank motors. Maintenance crews had to perform far more frequent and complex servicing, critically diverting manpower and significantly increasing vehicle downtime. The technical inferiority of this specific Ersatz product drastically reduced the operational readiness and performance of the entire German motorized and mechanized force. Synthetic rubber, Buna, proved particularly problematic for the heavy-duty, high-stress applications of the German military. The early grades of Buna rubber severely lacked the necessary elasticity, resilience, and resistance to tearing found in natural rubber, leading to vehicle tires that wore out quickly and tank track pads that disintegrated more quickly under the immense continuous stress of combat operations. This quality issue was severely exacerbated by the terrible road networks and harsh terrain of the vast Eastern Front, forcing logistics units to constantly seek replacements that were almost never available. The critical inability to rapidly replace worn-out tires and tracks was a constant, debilitating logistical headache, grounding vital trucks and tanks and severely reducing the operational tempo of German offensive and defensive actions. The entire Ersatz system, while providing crucial strategic materials, operated at an immense and ultimately unsustainable energy deficit. The processes, especially the Bergius coal liquefaction, required gargantuan quantities of domestic coal, water, and electrical power. To successfully produce 1 ton of synthetic aviation fuel, several tons of coal and massive amounts of electricity were needed. This created a profound economic paradox. The German economy was theoretically rich in coal, but was practically impoverished in net energy efficiency. Running the Ersatz economy meant systematically diverting enormous national resources, vast coal shipments, and crucial manpower away from other critical sectors, compounding labor and resource shortages elsewhere, creating a self-defeating spiral of economic inefficiency, and highlighting the inherent, catastrophic flaw in seeking autarky at any cost. The most horrific and morally bankrupt cost of the Ersatz economy was its widespread reliance on slave and forced labor. The synthetic fuel and rubber plants, particularly those designed and built by IG Farben, utilized concentration camp inmates and foreign forced laborers on a massive scale to operate the dangerous, high-pressure equipment and perform back-breaking construction and production tasks. The immense industrial complex at Auschwitz, the III Monowitz, is the most notorious and tragic example, where thousands of inmates perished working to create the Buna rubber and synthetic fuels. The production of Ersatz materials was thus inextricably and criminally linked to the systematic brutality and lethal exploitation of the Nazi regime, marking the deepest moral stain on Germany's scientific and industrial ambition. By 1944, The massive, overwhelming demand for spare parts, constant maintenance, and replacement Ersatz components far outstripped the rapidly diminishing German production capacity. The German supply chain, once considered a masterpiece of engineering efficiency, choked fatally on its own complexity and the low durability of its products. The critical lack of interchangeable parts, severely exacerbated by the localized, non-standard manufacture of Ersatz components, meant that simple, routine repairs quickly became complex, weeks-long affairs. The result was that tens of thousands of vital military vehicles and pieces of equipment were constantly idled awaiting repair. The Ersatz economy had proven wholly incapable of generating the necessary quantity to sustain total war, let alone the necessary quality to endure the harsh, grinding conditions of the Eastern and Western fronts. The ultimate, decisive failure of German autarky was delivered directly by the relentless Allied strategic bombing campaign. Allied intelligence, brilliantly identifying the synthetic fuel, plants as Germany's single most critical and targetable vulnerability, initiated the devastating oil plan in mid-1944. Beginning with sustained precision raids on major targets like the Pölitz and Leuna Hydrowerke, production of synthetic fuel plummeted from 124,000 barrels per day to virtually zero by early 1945. This was the final, irreversible death blow to the Wehrmacht. Without fuel, the Luftwaffe was permanently grounded, panzer divisions were completely immobilized, and the German war machine literally sputtered and ground to a halt, definitively proving that Hitler's massive Ersatz effort had only concentrated his economy's weakness into a few easily targetable industrial complexes. The history of Ersatz in World War II stands as a profound, chilling testament to German scientific ingenuity, a brilliance tragically harnessed for a morally bankrupt, fundamentally doomed ideology. While the chemical industry achieved technical marvels, pioneering processes like Bergius and Fischer-Tropsch that still influence aspects of energy production today, it was all for naught. The massive, centralized Ersatz economy failed because it could never overcome the inherent crushing economic costs, the fundamental inefficiency of synthetic creation, and the overwhelming, unsustainable material demand of total war against resource-rich opponents. Ultimately, the quest for self-sufficiency became a tragic, self-defeating strategy, consuming Germany's precious finite resources and its moral integrity, leading only to nationwide scarcity, systemic poor quality, and the final, catastrophic collapse of the Third Reich. If you enjoyed this video and want to see more, hit the like button and subscribe for more daily content.